In this video, we're going to go over the economic model called supply and demand. So we're going to do this in 6 stages. First, we're going to introduce the model and the idea of economic modeling. Then we're going to introduce some definitions. Next, we're going to go through what are called the determinants of supply and demand. Then we'll put these together to get equilibrium, and this gives us the idea of a market. Next, we will cover the idea of elasticity, which is closely related to supply and demand. And then finally, we're going to wrap up by explaining the example that I'm going to use throughout this lecture. So what is supply and demand? Simply put, supply and demand is a model. It is an economic model of how markets behave. It's an economic model of how markets behave. Models are important in all scientific fields and in all scientific literature because they are simplifications of reality. So the idea here is we take things that are too complex to tackle all at once, we make some assumptions and some simplifications, we work it down to a model that we can learn from, whether mathematically or through examples, and then we begin to understand something fundamental about what it is that we are studying. Of course, many scientific fields use this. Economics is no different than that. So what's happening in supply and demand and the market process is we are sorting out the coordination problem, and we're explaining how it is that markets and prices convey information and thereby build trust into a market situation. It should cause you, maybe a small amount of wonder, if you will, when you think about the way that you have implicit trust in complete strangers when you do any number of just amazing tasks. You go to your local grocery store, you never really stop to think about what are in these foods, but think about how many strangers, people you've never met and you will never meet, are involved in so many different parts of that process, from growing the foods, processing the foods, packaging the foods, transporting the foods, and then managing the foods there in the grocery store. And you'd think you couldn't trust a stranger with something so important as your nutrition and with so many risks as far as contamination or poor food quality, but you've never once thought about this. And the reason is this powerful market is solving this trust problem for you in a way that really allows you to have faith in the products that are being produced. Another good example of this is flying, right? Oftentimes you fly on a commercial plane and you never see the pilot. You might hear the pilot over the intercom, you might know the pilot's name, but you don't know anything about them or their credentials. How is it that you can trust somebody with something that is so inherently dangerous and risky? Of course, when I say that, you should be thinking, well, but it's not very risky. Flying is actually safer than driving a car somehow. But the fundamental act of flying is quite dangerous, right? If I were your pilot, you should be worried. But the reason that you're not worried about it is because it has a track record of safety, and it has a track record of safety because of the incentives applied in the market to figure out how to do this well, to do it safely, to do it in a timely fashion, and all the things that we like that flying and any other market end up giving us. So supply and demand is important, and in economics it's especially powerful tool because we often cannot do controlled trials in economics, right? Some fields of study have what we call field experiments, and that's kind of what we end up having to do in economics. And so we need this model in order to control for the differences that we observe in the world, right? Think about some other field of study. Biology or physics would be good examples of this, where you can have a laboratory study and you can control things, and then you can change small variables and begin to learn and study the world. In economics, we can't do that, right? We can't randomly assign inflation to one nation but not to another and then see what happens, right? That's unethical. It'd be bad for the participants. It's not even really a feasible thing that we could do, even if we ignore the ethical considerations. Bankruptcy would be similar. We can't study bankruptcy in economics the way that we might be able to study gravity in a controlled trial, because we can't assign bankruptcy to one group of people and to not assign it to another, or assign some kind of placebo effect to another group. We can't do that. Literally, that's impossible. And so what we end up having to do is look at what happens when nations have episodes of inflation. What happens when there is bankruptcy for certain individuals, but not for others. But those are non-randomly selected. They made decisions to get to that point, and those decisions might be the things that are determining what the outcomes are. So we have to have these models and some assumptions that go with them in order to be able to study this. Okay, so there are many assumptions. There are quite a lot of assumptions in supply and demand, and if we're doing, a principles micro class in particular, I would go into a lot more of these. For the sake of this class and how I'm going forward and going throughout this course, I'm going to keep it down to two simple assumptions. And these assumptions tell us when it is valid to use supply and demand. And really, even if it's not fully valid in a particular case, we still want to learn something in principle about markets, prices, supply and demand, etc. So the two assumptions I'm really going to build on are what's called homogeneous goods and many buyers and sellers. So homogeneous goods is the idea that what it is that we are selling and buying are the same thing, right? And so this is an assumption that we'll relax later on in the class. But to start with, we should be talking about a situation where the goods that are being sold are the same, right? So when we're thinking about classic examples of this would be agricultural products or commodities, right, where a bushel of wheat is approximately the same from farmer A and from farmer B. You wouldn't be able to tell them apart, right? And this is important because what that does is that gives us an elastic demand curve, right? And so what happens there is if you're choosing to buy this product, you're deciding based on price. Okay. Similarly, many buyers and sellers gives us the assumption that there's no market power. So even though different producers will technically be able to choose what price they set in a very, very competitive market where there's many people selling and many people buying, if you move away from the market equilibrium price, you're not going to end up being able to sell any of the goods. And if you're a buyer and you're not willing to pay a particular price, but that's the price the market has set, you won't get any of the product, right? So we're just saying this is a very competitive market. So let's define supply and demand. Let's start with demand. So demand is the willingness to pay for a product from people who would potentially be buying that good or service. So I said product, but remember this is good or service. This is subjective, right? And that's because value is inherently subjective. When we look at something, we want to say things have objective value, but that's not possible because the value that we place on things must be related to how we would benefit from it or use it, etc. So, for example, think about a situation, something simple like water, right? This is a classic example that we see in some of the early economists known as the Austrian School of Economics. If I'm in a desert and I'm running low on water and I still have 100 miles to walk, the value of the water that I might have would be very, very high, right? If I'm have plenty of drinking water, plenty of water for cooking, plenty of water for cleaning and taking a shower, brushing my teeth, etc., and I'm considering what's the value of another gallon of water, I got to think about what it is that I'm going to use it for, right? And this gives us the idea that value is not only subjective, but it's also marginal, right? So it depends on which unit it is that we're looking at potentially consuming. If I'm going to use this gallon of water to water my lawn or to wash my car or to make a pool for my kids or something, this is a different value than if I'm drinking it to stay alive, in a desperate situation, right? And so we want to remember that the only way that things can have value is depending on how it is that people value them. And that's inherently a subjective prospect. Okay, so remember that value is marginal and subjective, right? So it depends on how many of them we have, how many of them are available to us, what it is that we're going to do with them, and how we value those tasks that we're going to use the particular good or service for that consumption. Okay, so it's very important to think about how demand is related to price. Okay, so price is saying how much are you willing to buy at a given price, and that'll be the market demand, the individual demand, and the market demand, of course, is the individual demands all aggregated or added up, right? So the market demand is the sum of all the individual demand curves. So what is supply? Supply is the flip side of demand. It is the willingness to accept. So if I'm selling something, what price will I accept for this good? So both supply and demand are about the willingness to pay. Notice that I'm not talking about need. I'm not talking about anything, but do you have the capacity? You're both willing and able, right? So I have goods that I would like to buy. I might like to buy a fancy car, a Lamborghini or something like this. And so I'd be willing to buy it, but I don't have the income, so I'm not able to buy it. So I'm not demanding that good. Okay, so we have to be willing and able. It's the same with supply. We have to be willing and able to sell a particular good. Now, because of the way that value works and the way that we think about the use of particular items, Austrian economists are fond of saying supply is just demand in disguise, right? Because we're selling things in order to get other resources that we're going to use for other tasks. And so it's really that process that is just one step removed from demand. So supply is demand in disguise. So the price, what's the relationship between supply and price? And that is the how much here is the quantity supplied, same as the how much here is quantity demanded, is how much will the seller make available at every given price, right? So we could think about this as an example. If I have something that's very valuable to me, right? I have a car that was given to me by my grandfather as my inheritance, right? And let's say it's a nice car. It's an old hot rod or something like that. That has a certain value to me. It is very high value to me, in part because of the subjectivity of that, right? And if my grandfather had given me 10 cars, right, well then it would be I'd be on a different margin. Maybe I could sell one of those cars. But if I sold 9 of them and had one left, the value of that last one, or if he only gave me one, might be very, very high because of the sentimental value, and I might like the car, and my relationship with my grandpa was important to me, right? Am I going to sell that car? Most likely not. But what if somebody came along and they needed that one particular car to complete their collection? They're a very, very wealthy individual, and they start offering me twice as much as the car's worth, 5 times as much as the car's worth, 10 times as much as the car's worth, right? Eventually they'll find some number that's going to, set up my family for the rest of our lives, that I probably need to part with that particular car, right? And so we can think about the relationship between, selling things, supplying things, and the price in that kind of way. Okay, so let's take this example here to sort of work through how supply and demand works in a mechanical way in the model. And the example that I'm going to use is 2 cards in 1955 Bowman cards, right? So Bowman is a card producer, one of the big card producers today, one of the long time. Of course, you'd have heard of Topps and some others. Bowman is another quintessential producer of baseball cards. And they produced 2 cards back in 1955, a Mickey Mantle card and a Hank Aaron card. Okay, so Mickey Mantle was a very famous baseball player, played for the New York Yankees, played from 1951, and he's 14th all-time in wins above replacement. So remember our sabermetrics from a few lectures ago. Wins above replacement is an idea. It's a cumulative stat that measures the productivity of a player compared to a bench player, compared to a replacement player, compared to a player that would replace you if you came off the bench. So they're saying there's this amount of production that's sort of the baseline production of an MLB player that's good enough to be in the majors but isn't going to start a lot of games. They're a bench player, and they call them replacement level players. And then every year we can measure the amount of productivity from different positions do different things, obviously, but for fielders like Mantle and Aaron, their defensive production, and of course, most importantly, their hitting production. And we can add those numbers up every year, so we can have, if you had 2 wins above replacement one year, 5 wins above replacement the next year, you'd have 7 total wins above replacement for those 2 years. So a quick word on that. It's called wins above replacement because they translate your production into the runs that you've saved or the runs that you've created, which of course can help us understand how many wins that would contribute for the team, right? Because if I score and drive in and prevent a lot of runs for my team, then I'm very valuable to that team, and those runs that I've created or prevented for the opponents are then give us a higher probability of winning games, right? Well, all time, so we're talking about an impressive list of players. Mickey Mantle is the 14th best player in history by this measure. Okay, so of course there are many complex things that go into all of this, but we're saying Mantle is approximately the 14th best player in Major League history. We're talking about the 14th best player ever. A couple of quick facts about Mantle. He spent his entire career with the New York Yankees, and he's considered one of the greatest baseball players of all time. Known for his offensive prowess, including the ability to hit for both average and power. He holds records and achievements, including being the greatest switch hitter in baseball history, winning the Triple Crown in 1956, and holding numerous World Series records. Of course, playing for the Yankees, he played in a bunch of World Series. A similar career during the similar time was Henry Hank Aaron. He played from 1954 to 1976, mostly for the Milwaukee and Atlanta Braves. He's 6th all-time wins above replacement, so arguably the 6th best player of all time. He was nicknamed Hammer and Hank and was a right fielder who played 23 seasons in the MLB. He held numerous career power hitting records, including breaking Babe Ruth's home run record for a single season, the record for runs scored, and was the career home run leader for 33 seasons up until 2007. He held records for RBIs, extra base hits, total bases, as well as being an all-star for 25 seasons. He also won an NL MVP award. So let's take a quick look at their statistics here. You can see Aaron played more games, having nearly 4,000 more, about 50% more at-bats. He had many more hits, 1,300 more hits about. Several hundred more runs scored. Of course, this 755 is a legendary home run number, but of course, 536 is also an impressive number for career home runs. We see that Aaron also had about 700 more RBIs. That's a typo. That should be .305 batting average, but hit for a higher average. All of these things would make us think Aaron is the better player in this situation. And yet, when we look at the card prices of these two mint condition Bowman 1955 cards, we see that the Mantle card is substantially more expensive. So I'm going to work through the supply and demand model and introduce some concepts that'll help us kind of understand and maybe explain this puzzling thing that we see here. We're going to start by building our supply and demand model, and we're going to start that by doing the determinants of demand. Okay, there are many, many determinants of demand, and the list can be almost infinite. If we work through an example of demand for a different product, we could think of lots of things that would go in there. So I'm talking about broad categories and things that are very common to basically all demand curves here. The first one is income, and income is broken down into two categories: inferior and normal goods, right? Or goods or services. So an inferior good is one that when your income goes up, you consume less of it. An example of this, like the classic example, is like inferior foods like ramen, right? Ramen is still quite a good food, but for most people, because it's inexpensive and not a very complex food, if your income goes up, you're going to eat less ramen. What's an example of a food that if your income goes up, you'll consume more of it? Maybe steak or other like quintessential high-end foods. Now, I'm going to get to this in a moment, right? But all of these things are determined by the individual. Some people hate steak and love ramen. And so what is an inferior or normal good is going to depend on the consumer that we're looking at. But on average, right, ramen is probably an inferior good. Most people consume less of it if they have more income. So an example of this in our situation, if we think about baseball cards, is minor league cards might be an example of an inferior good. If you have less money, you might buy these cards. Like if you go to a minor league baseball game, they'll have baseball cards that have been produced of all their players. And so it's not like Topps or Bowman. They're just cards that are sort of being produced just so that when you go to the stadium, if that's something that you care to buy, that they're available. So I mean minor league cards, I mean cards that are sort of sold by the minor league teams, right? So if I have a card of a famous baseball player from back when he was in the minor leagues, that's not necessarily an inferior good. But baseball cards themselves are probably a normal good. If you're a person who collects baseball cards and your income goes up, you're likely to spend more money on baseball cards. So what does that look like? Let's do this very quickly just so we can visualize this relationship, kind of refresh your memory. So we've got the price quantity axis, right? And we have a demand curve, and this demand curve shifts outward if we're looking at a normal good, and our demand goes up. So we move our demand to the right in that case. And so what I'm saying here is at a given price, I'll buy more if my demand goes up. Here you can see quantity 2 is higher than quantity 1. Okay, so income is an important thing to think about, and one of the main things that affects income at the aggregate level, at the macroeconomic level, is recessions. So some people ask the question, are sports recession proof? Are sports recession proof? Well, we saw following the 2008 recession that attendance actually held up, but it did so at the consequence of ticket prices falling, right? So sports game attendance, ticket purchases, they're not recession proof because the prices had to fall in order to sort of keep attendance up, right? So that's one way we'd think about income and ticket prices. It's very interesting to sort of look at some of the way that this was approached by the media at the time following the 2008 recession in the NBA. We saw articles titled the No Benjamins Association because of the difficulties that the NBA faced. In the MLB, we saw articles titled Baseball Battles the Slump, right? So that's a play on words for slump being in a situation where a batter's having a hard time getting hits. In NASCAR, we saw articles titled Daytona Drag. We saw NASCAR facing the fallout from the economic recession. And then, of course, we saw stories where this affected golf, LPGA facing economic realities. I find the titles and the different cleverness and play on words versus sort of very straightforward approach of golf to be pretty amusing. Okay, next determinant is related goods. And there's two types of related goods. There are complements. Notice that there's two E's here. Complements and substitutes, right? So it's something complements another thing when it goes with it, right? And a substitute is something that replaces something. In the case of cards, this might be cases or sleeves that protect cards. If you get a nice baseball card, you want to protect it, you put it in a hard plastic case or in a plastic sleeve to keep it from being scratched or bent. These are things that get consumed along with it. So if the price of the sleeves, let's say, just goes way through the roof, it's very expensive to get these protective cases for the cards, your demand for the card will go down. Let's think about some other things that we might consume. We consume milk and cereal together, right? And so if the price of milk goes down, we might eat more cereal because of that, right? So this shows us how complements the relationship between two related goods, if their complements, might work. Okay, next is what we call substitutes, right? So if we're buying sports memorabilia, a substitute for a card might be other types of memorabilia like a jersey. Well, if the price of jerseys go down, I might buy fewer cards in order to buy more jerseys. What are some other substitutes? Pepsi and Coke would be a classic. You go to the store, you have a slight preference for Coca-Cola, but you see the Pepsi's on sale for 50% off. That might be enough to induce you to buy the Pepsi, so your demand for Coke goes down. Okay, as promised, we want to talk about tastes, or as economists call them, preferences. So this is saying if we have a good that we might care about all these other relationships, income, complements, substitutes, all these different things that we might care about. For some individuals, if we're not consuming that good, or we might relate to it as an inferior good, we might relate to it as a normal good, we might not think of things as complements, right? Some people eat odd things together. My father is half Korean, and so he likes kimchi. And kimchi is a classic Korean dish, right? But he likes to eat kimchi with all manner of other foods. Like one of his favorites is kimchi and Cheerios, right? And so personally, I don't like kimchi, so my taste and preference for kimchi is low, and not representing my Korean heritage very well, perhaps, in that. But to me, kimchi and Cheerios are not complements. But for my father, they are complements. He likes to eat them together, right? And so the taste and preferences inform what are the related goods, or normal and inferior. But they also have a direct effect on the economy. Okay, so if your taste or preference for something goes down, your demand for that thing will go down. So let's take a look at this. So if we have this demand curve, our taste goes down, demand curve falls, then at the same price, we'll desire lower quantity than we would have before. So that's what it looks like when demand falls. Okay, another obvious one is just the number of consumers, right? So if we have more buyers, then demand for the product will go up. Okay, one last determinant here, or really two, is what we call expectations. And we can have expectations of price and expectations of income. So if we expect the price of something to go up in the future, we will consume more of it now. What's the classic example of this, right? You know, July 4th is coming, you know, Thanksgiving is coming, there's going to be lots of travel for the holidays, your gas tank is close to empty, you can wait to buy, or you can buy gas now. Which should you do? Well, you think the price is going to be higher in a week if we're coming up on a holiday, so I better buy gas now. So your demand now goes up if you think the price is going to go up in the future. Of course, this works the other way as well. If we think the price is going to go down, then we wait to buy it, which means the demand that we have for the product now will end up falling. And this would be like we're waiting for something that we care about to go on sale. The similar relationship with income. If you think your income is going to go up in the future, you might consume more now. You're a year away from graduation. You're pretty sure the degree that I'm getting is going to get me a good job. I'm going to make a lot of money. You might spend a little bit more this year because you know I'm going to make more in the future, right? And so likewise, if you expect your income to go down, you're worried about there's a good chance that you're going to get laid off next year. You're probably going to spend less this year to try to prepare, save some money, and be ready for if you get laid off. Okay, this is related to an idea we call consumption smoothing. Actually, let me redraw this so that it's more clear. So our consumption over time might, if we just very closely followed our income, might look like this, right? So let's just take this as a brief example, right? And so our income goes up here, right? And so it might be the case that, oh, we were going along, we consumed this much, we made more money, we consumed this new higher level. And if that jump in income surprised us, right, if we got a raise that we weren't expecting, it might really look like that, right? But more likely, we would see some kind of behavior like this, right, where we smooth our consumption between these two time periods. And what does this mostly look like? Well, beforehand, we're borrowing a little bit, and then afterwards, right, we're paying off those loans, right? So our total borrowed money will end up going down because we're paying it down as we go. So how might we think about this example? Let's do consumption smoothing, like an example that we can think of a little more cleanly. So you come to class, I give you 2 candy bars. Are you going to eat both candy bars today, or might you eat one now and one tomorrow, perhaps? Well, most people are going to smooth their consumption out. I'd rather have 1 candy bar today and 1 candy bar tomorrow rather than 2 now and 0 tomorrow, or 0 now and 2 tomorrow, right? So that's kind of a simple example of how consumption smoothing might work. Okay, we've done demand. Let's look at supply. So supply has 5 determinants that we're going to cover in this class. The one that probably everyone's thinking of is input prices, right? So if I'm making baseball cards, I'm using cardstock, I'm using ink, I'm having to pay for the rights to use MLB logos and player pictures, etc., right? If these go up, my profitability goes down and the amount of them that I want to supply falls. So we can always think about profitability as a proxy for these kind of things. Another determinant of supply is technology, right? And this helps us in production. Technology in production is really how we think about that. If my technology improves, my ability to produce these things goes up, then the amount that I will supply will also go up. So what are some things that are technology in the baseball card world? Obviously printers, cameras, packaging that I put these cards in are all technologies or applications of technologies. Of course, in the world that we're living in today, there are really unusual types of technologies like non-fungible tokens, where we sort of have digitized cards that are the ownership of these things is determined by blockchains. And so we can see kind of new technologies emerging. Next, we might consider taxes. Tax is pretty straightforward. If your taxes go up, the amount that you're going to supply is going to go down. Let's look at this sort of like we did with demand, right? If we have an initial supply curve and supply falls, it shifts to the left. This is a little confusing, right? Because it looks like it's going up, but just always be thinking left and right, especially with supply when we're working through the models in this class. How do we know that that's a decrease in supply? Well, at the same price, I was buying quantity 1, now I'm buying quantity 2, right? So at this price, how much do I buy in the supply 1? I buy that much. At this price, how much do I buy with supply 2? I buy this much. That is a decrease, okay? So that kind of helps us understand how that works. Okay, so in the same way that we have expectations for demand, we also have expectations for supply. Of course, in this case, we care about the price of things. So if I'm going to sell something and I think I can get a higher price in the future, I will sell less now, right? As a producer, I say, well, I can get more if I just wait. I'm going to hold on to my stock until the prices rise. Another classic supply determinant is natural events, right? Like often we have natural disasters that disrupt supply chains, right? And so our natural events typically have an inverse relationship with supply. Okay, now that we've got supply and demand, so supply is upward sloping because as the price goes up, the amount that suppliers want to supply goes up. As the price goes up, when we're looking at demand, it's downward sloping because as the price goes up, the amount that we want to buy ends up going down. So let's look at how equilibrium works really quickly. Say the initial price is very low. Then demand, the quantity that we're demanding, will be very high. Whereas at this low price, quantity supplied is very low. This is what we call a surplus, right? There's a lot of goods out there that are unsold. What happens in that case? Of course, the price, I'm sorry, this is not a surplus. This is a shortage. This is a shortage where the amount that people want to consume is much higher than the amount of the goods that are made available, that exist. In this case, if there's a shortage, the price of the stock will be driven up, such that the price will rise. As the price rises, the amount that consumers want to buy goes down, and the amount that producers want to make available goes up. This continues until we reach the equilibrium price, where the quantity supplied falls equal to the quantity demanded. It works similarly if the price is out of equilibrium, too high. If the quantity supplied, because the price is very high, while the quantity demanded, because the price is high, is very low, we end up with a surplus. In this case, to clear a surplus, you have to put things on sale, and the price comes down, right? So if you go to a store, you see they've got a lot of shirts that nobody wanted, so they have this extra stock. What do? They put them on sale. As the price begins to come down, we see that the quantity supplied, the amount producers want to make available, comes down. The amount that consumers want goes up, until once again we have the equilibrium condition of quantity demanded equal to quantity supplied. And we call that equilibrium. Okay, let's take a look at then how the determinants, which determine the location and shape of supply and demand, how that sort of works in an example. And let's take a classic example from sports economics, and that's left tackles. Okay, so there was a period in time where, let's start with what left tackles are. Okay, so in football, right, we have offensive linemen, offensive players denoted by circles, facing off against defensive linemen, notated by the X's here, right? And this player that I've highlighted here is the quarterback, right? And the quarterback is the person to whom the ball is snapped. And in older iterations of football, the game was heavily predicated on running. And so the quarterback might do some running, and then he would also hand or flip the ball to the running back, and he would run a different direction, right? And they would try to confuse the defense or take advantage of different strategies against the defensive line. However, over time, the NFL, and really all of football, but the NFL really became much more of a passing league. And this led to a concept called the blind side. And the blind side is that when this quarterback, who's typically right-handed, goes to throw the ball, he needs his right hand downfield while his left hand is facing upfield, which means he has more vision to his right than he does to his left. As a consequence, defenses began to place their best pass rusher here on as the left end, right? Of course, in recent iterations of football, we have very highly specialized player called edge rushers that work to sack the quarterback, and they employ many kinds of strategies. But as a typical, we see them on the left side of the line when from the offense's perspective. So as the league began to pass more, left tackles became more important. So the taste and preference for teams to hire left tackles went up. As a consequence, the demand for left tackles goes up. So bear in mind, right, we're looking at the market for left tackles. So who supplies the players? They supply left tackle play. And who buys? Teams, right? They consume in this case. Okay, so the demand increased. The demand for left tackles increased, right? Now, at the same time, right, we saw, and I'm going to use a short run effect here because obviously NIL is a very complex issue. We've seen recent years, there's name, image, likeness come to college football, right? So you basically can get paid for any sponsorships or et cetera while you're playing college football, and you can still be an amateur athlete, right? And so in the short run, right, players are likely to want to stay in college rather than be drafted low in the NFL. For some players, that's not a factor, right? I make NIL money playing a year or two of college football, then I get drafted first overall, I'm gone, right? But some players, it's going to be better to take their sponsorship money, play some college football, rather than maybe go undrafted or and then have to sign a non-drafted deal, or go low in the draft. So I might want to stay another year. NIL might make it the expected payoff of going to the NFL relatively lower, right? Because the price of the NFL stayed the same, but the opportunity cost of college went up. And so in the short run, right, the long run effects are likely to be different. So I'm just talking short run effects here. As a consequence, the supply of left tackles in the short run, the supply of left tackles in the short run might fall. Supply of left tackles in the short run might fall. Okay, so now we have this new equilibrium point here, right? New equilibrium point here. One thing is very clear. The price of left tackles, the net effect, will be an increase. Now, what happened with quantity? The way that I've drawn it, you say, oh, well, it might be slightly to the right here, but that's sort of an artifact of the way that I've drawn it. What we want to do is we want to do some analysis. So if our demand increases, right, so this shift here, we know that the price increased, and we see that the quantity increased. So price increase, quantity increase. Now, if supply goes down, we see that the price will go up, right? From here to here, the price goes up, but the quantity goes down from here to here. That means the obvious effect on net to price is increase is a net increase. The problem with an increase and a decrease in quantity is that we don't know what the net effect is. So when we're doing any supply and demand, we've got multiple shifts, we want to do some analysis on how these. Now, it might be the case that, the supply bump was really small and the demand bump was really big, and so the quantity is going to go up, right? And so these effects may not be the same size, and I've kind of drawn them to where they're roughly the same size and the same shape of the curves, but we're seeing that it's actually going to be two very different things potentially, depending on the size of the shifts. But we want to do some analysis in this case, and what we can say is something will happen to quantity, but what it is an empirical question based on the size of the two shifts relative to each other. Now, it's not always going to be the case that quantity is unknown and price is known, right? If we move supply the other direction, then it would be the opposite effect, because the price would go down for supply and the quantity would go up, and so we would know that quantity was increased, while the price, we wouldn't know what the eventual effect. That would be an empirical question. Okay, let's turn now to elasticity. Elasticity, very simply, is the sensitivity to price. There's lots of different types of elasticity. In this case, we're going to do what we call own price elasticity, right? Because we have related goods. You can also have cross price elasticity. You can have elasticities related to income, right? Basically, all of our determinants of demand have some kind of elasticity related to them. For the purposes of this class, when I say elasticity, I'm going to always mean sensitivity to your own price in this case, right? Okay, so let's start with a very sensitive, what we call elastic supply curve, right? So if the price goes up a little bit and the quantity changes a lot, that means we're very sensitive to changes in the price, and the supply curve will be closer and closer to being flat, right? The sort of classic elasticity is what we call unit elasticity. This is a 1-to-1 ratio. So if we have a 1% increase in price and we get a 1% increase in quantity, that is unit elastic, and that gives us this 45-degree line where the same size shift in price and quantity. Now, inelastic means we are insensitive to the price. That means a big change in price might lead to a small change in quantity, and the more inelastic we are, the closer the line becomes to vertical. So what might be some examples of inelastic demand? A good example will be things that we're addicted to or things that we absolutely have to have. So for addiction, right, drugs are going to have a very high, cigarettes might have a very high, very not high elastic, very inelastic supply, demand curve, right? And we'll see that the bigger the price change for something that people are wanting to consume, but the less they respond to it, the more inelastic they are. Okay, so our equation, there's many different equations. In this case, we're going to use the midpoint formula, and that is the percentage change in quantity over the percentage change in price gives us the elasticity. And in this case, I'm showing you elasticity of supply, but it's the same formula for elasticity of demand. So this elasticity, if the absolute value of it is greater than 1, we are elastic. If the absolute value is 1, we call that unit elastic. If the absolute value of the elasticity is less than 1, we call that inelastic. Okay, so our formula then is very simple. It's just the change, right? Q2 minus Q1, the change in quantity divided by the price, that gives us the percentage, over the change in price divided by the original price, giving us the percentage change in price. Let's work an example to sort of make these things concrete. Okay, so we're looking at baseball cards. We say, okay, a pack of cards or a card is 10 cents and the price goes up to 11 cents. Okay, we'll work two different examples so that you can see. In example 1, the initial quantity is 1,000, and because it's supply, the quantity goes up to 1,200. Let's do each of these examples in turn. Let's start with example 1. So I'm going to write out the equation for us first. So it's quantity 2 minus quantity 1 over quantity 1. So we get our percentage change in quantity. Divided by the price for 2 divided by, minus price 1 divided by the price for 1. Let's just plug in our numbers here. So we get 1,200 minus 1,000 divided by 1,000 over 11 cents divided by minus 10 cents divided by 10 cents. Okay, we can simplify this down very quickly. 200 over 1,000, 0.01 over 0.1. So we can cancel this out. So we'll see this will be 2/10. For simplification purposes, right, we can move this over so that we get, I'm going to do this all in one fell swoop. 2 over 10 is the same as 1 over 5. We move 2 decimal points so we get 1 over 10. The trickiest part is probably invert and multiply. And now, of course, we'll easily see we get an elasticity of 2. So remember, our absolute elasticity greater than 1 means elastic. Simply put, we saw a 20% increase in production for a 10% increase in price. So I won't reproduce the formula since now you've seen it and you're comfortable with it. What if it's 10,200 minus 10,000 over 10,000, and then it's the same price numbers here. So now we've got 200 again, but it's over 10,000. And we've got the same numbers here, 0.01 over 0.1. I'm going to do the same thing, but now we've got 2 over 50. I'm sorry, 1 over 50. 1 over 50 instead of 1 over 5. And then, of course, we can again simplify this like so, such that we get 1/50th times 10. And so we get 1/5, or 0.2 instead of 2. We see that the absolute value of this is, less than 1. It's a decimal now. And so instead of elastic, it's inelastic. Now that we've got elasticity, let's circle back around to that card conundrum. We're going to start, as we do with models, with a couple of assumptions. First, we'll start with our weak assumptions. Very simply, we're going to assume that the same number of cards were produced of both type of cards. It's a very normal assumption. May or may not be true, but it's not necessarily a radical thing for us to assume. And then let's also assume the same number of mint cards made it from their original production to the collections that we see today. On the other hand, we have to make some relatively strong assumptions, and that is there's a fixed number of cards available. So we're saying it must be that the same number of cards are for sale today, and that they're insensitive to price. If the price of the mantle cards goes up, it doesn't cause more people to want to sell the mantle cards. So the cards that are for sale, and what price they fetch is going to be a function of demand. Now, we can use these determinants that we've introduced to kind of analyze the situation. Let's look at the number of buyers. Well, importantly, Aaron played in Atlanta for much of his career, while Mantle played in New York for much of his career. So which of these has higher population? New York does. So there's going to be more buyers, and as a consequence, higher demand for the Mantle card than the Aaron card. Taste and preference, right? The Yankees as a brand are one of the most famous sports teams in all of history, while the Braves, certainly a popular and famous team, are much less famous, right? And so it might just be the case that Yankees cards are going to be more popular and therefore have higher demand than Braves cards. And then, of course, finally, income. Atlanta has a median income of $36,000, whereas Manhattan has a median income of $300,000, almost tenfold. And so we're seeing all of these things are going to show a higher demand for the Mantle card than the Aaron card, even though Aaron was statistically the superior player. And this explains the gap in prices.